Hello, I will talk about special relativity and the twin paradox. Special relativity is an explanation of how speed affects mass, time and space. As an object, as an object approaches the speed of light, the mass of the object becomes infinite, and so does the energy required to move it. This means that it is impossible for any matter to go faster the speed of light or even reach the speed of light. Now I will talk about the twin paradox. The first twin flies into space at a very high speed, for example 240,000 kilometers per second, and returns to Earth while the second remains on Earth. According to the theory of special relativity, movement at high speed slows down the flow of time. So the brother who went on a journey in space will return to Earth 10 years younger than his brother who stays on Earth. Now I will talk about the twin paradox in detail. One twin remains on Earth while his brother moves away in a spaceship at very high speed, close to the speed of light. At some point, the brother turns around and returns to Earth. According to the theory of relativity, the journey in the spaceship will take less time on Earth, which will lead to the brother in the spaceship returning younger than the brother left on Earth. For example, suppose the journey is to the star Epsilon in Eridanus, which is about 10 light years away from the solar system. At the speed of the spacecraft is 80% of the speed of light, that is to say 240,000 kilometers per second. According to the twin left on Earth, the round trip time measured on Earth is T naught equals 2 times L naught divided by V equals to 2 times 10 divided by 0.8, and the total time is 25 years. So the distance between Earth and the star Epsilon is 10 light years. And the twin that is in the spaceship actually travels back and forth. So the total distance that it travels is 2 times 10 light years, that is 20 light years. And it travels the 20 light years in the speed of 80% of the speed of light. That is 240,000 kilometers per second. So the total time that it takes him to do all the journey is 25 years, according to the brother, to the twin that is on Earth. Okay. And according to the Lorentz transformation, the time measured by the twin in the spacecraft is T spacecraft equals to T naught times root of 1 minus V squared divided by C squared equals to 25 times root of 1 minus 0.8 squared, and the final result is 15 years. So because of the fact that the twin brother that is in the spaceship travels at very high speed, then the rate of time flow in the spaceship will be slower than the time flow on Earth. This phenomenon is called time dilation. So because of time dilation, the journey of the twin that is in the spaceship will be only 15 years instead of 25 years, that is from the point of view of the brother that is on Earth. So because of the fact that there is the time dilation, the journey of the brother that is in the spaceship will take only 15 years instead of 25 years. So the journey will be 10 years less than the journey that is from the point of view of the twin brother that is on Earth. Because of time dilation. So, according to the twin in the spacecraft, he is at rest, while the Earth on which his twin brother is and the star Epsilon in Eridanus are moving across it at a speed of 80% of the speed of light. As a result, the distance between them shrinks to according to the Lorentz transformation. So the distance it must travel is L spacecraft equals to L naught times root of 1 minus v squared divided by c squared equals to 10 light years, that is the distance from Earth to space according to the brother that is on Earth, times root of 1 minus 0.8, that is the division of v square by c square, 0.8 squared, and the final result is 6 light years. So as we can see here, the distance between Earth and the star Epsilon contracted to 6 light years only. So there is a 40% contraction of the distance between Earth and the star Epsilon, because it contracted from 10 light years to 6 light years. And the total time that it will take to the brother that is in the spaceship to do all the journey will be T spacecraft equals to 2 times L spacecraft divided by V equals to 2 times 6 divided by 0.8. The final result is 15 years. So when someone or something travels at a very high speed towards you, there will be a contraction of distance between you and the object travels at very high speed. And this is according to special relativity. So the total distance that the brother in the spaceship must travel back and forth is actually 12 light years because of the fact of the contraction of the length. Yes? So the total distance back and forth from Earth to the star Epsilon will be only 12 light years, and is traveling in the speed of 80% of the speed of light. So it is 12 divided by 0.8, and the final result is 15 years. So we see that the journey of the twin brother that is on the spaceship is 10 years less than the journey that the brother that is on Earth measured on Earth. So therefore, the two twins effectively agreed that the twin in the spaceship will be younger when they meet again, in terms of the twin that remains on Earth due to the effect of time lengthening, and in terms of his traveling twin due to contraction of distance. Thank you very much.